Martian winter. So I'm Ashley Stroupe, and this was your Free Spirit update.
All right, with us now is Ashley Stroupe. She's one of our rover drivers, and lots of people have no idea how these rovers are operated on Mars. Spirit and Opportunity, you're not driving them with a joystick and, okay, avoid that rock, you actually have to program it. So before we go any further, let's just explain to folks exactly what a rover driver does.
Sure. Well, it is like driving a car with a computer program. So every day we have to sit down and look at the images of the world around us and figure out where the rover is going to go. And then we have to build a program, essentially, that will guide the rover along that desired path.
Let's go to the video, and you can show folks.
I can show some examples.
Let's go to the videotape. And this is the rover driving. So you are in a room, essentially.
Right. We sit in a room at a computer terminal where we can pull up all of the images. Here you can see two of my colleagues evaluating some terrain from Opportunity. And they're looking at the potential hazards. They're looking for any rocks, any hills, any loose soil that they would want to avoid driving into. We can also look at these images in 3D. And so we can see Mars the way the rover would see it or the way we would see it if we were there, so we can get a better of assessment. There you can actually see the 3D glasses that we use to be able to look at the terrain and predict what rocks are dangerous and what rocks are safe to go over. And we also have tools where we can measure things in the image using the stereo models that the rover has built for us. So we can see if there are any rocks that are dangerous for the rover to drive over. And then once we've assembled the plan of what we want it to do, we sit down and we write the program and build the sequence of commands. And then we simulate those commands. We play them back in a full model of the rover and the terrain so we can see how the rover is going to interact with the terrain. And we do that both for driving or, as you can see in the video, this is an example of testing out the robotic arm, the IDD, and a sequence of commands for placing an instrument.
How involved is that? Do you meet, once a day and figure out the marching orders for the rovers every day, or what?
Right. So pretty much once a day, we sit down with all the engineers and all the scientists, and we come up with the general plan of what the robot's going to do for that day, where it's going to drive, or what targets it's going to look at with its science instruments. And then each sub-team goes off and builds their part of the program, and then we come back together and we walk through every line of the program that's going to go up to the rover twice before we then send it to the rover on Mars. So we then send the plan up, the rover then executes the plan, and then at the end of the day, she calls back home and lets us know how everything went. So we have to often wait a long time before we know how things went on Mars.
And what's involved in the planning? Isn't it mostly scientists saying, boy, that rock over there to the right really looks interesting. Could you get us over there?
Right. We are a science mission. As exciting as the engineering is, we really are a science mission. So it all begins with what the scientists sit down and they say, this is what we want to do. Here are the interesting things around here, and we want to go look at these things. And then we try to evaluate all of those different places they want to go, and hopefully we can accommodate all of them, but sometimes something might be too dangerous or too difficult to reach, and we have to tell them, well, we can't quite do that, how about this? And so there's a little bit of negotiation going on. But we do start with the science first, and we really try to get the scientists what they need, because ultimately that's what we're trying to do.
Well, the purpose of our talk today is figuring out ways to free spirit.
Right.
And here we have a suggestion here from someone on Ustream. Why don't you use a harness to make the test rover weigh the same on Mars? Do you really need to do that, though?
Well, sometimes we do have to do testing, and in fact, when we're first building a robot, we often do that kind of testing to exactly simulate what Mars gravity would have. But our test rover is actually lighter weight than the one on Mars, so it's not quite down to Mars gravity, but it's part of the way there. And actually, that is a close enough model for the kinds of things we're trying to do. Actually, the rover being a little bit heavier actually makes driving in this stuff a little bit harder. So we're sort of modeling the worst case, if you like, by letting the rover be a little bit too heavy for Mars.
I think a lot of people are learning about that for the first time, that we have two different rovers. There's a test rover that's the same weight as the rover on Mars.
Almost the same weight. It's missing some of the batteries and the solar panels and some of the other heavy components, but it's very close to the weight of the rover on Mars.
And I'm not sure very many people realize that there's a difference in having to factor in gravity.
That's right. Of course, the gravity of Mars is a little under 40% that of Earth, so things weigh about a third there that they do on Earth. And, of course, how you interact with the ground is very dependent on your weight. So sometimes you really do need to take that into account when you're modeling things.
All right. We're going to some of the email questions now.
Great.
This one's from Mark Parker. Could the denser material be placed under one wheel at a time on the soft side to raise that side enough to clear the object underneath?
You know, that's a good suggestion. A lot of people have been thinking about that kind of thing, but unfortunately we don't have any way to transport material under the wheels. The arm could only reach the front wheels anyway, but it also isn't really strong enough to move large amounts of material. Particularly, we'd also be at risk of damaging some of the science instruments if we actually tried to interact with the ground in that way. So unfortunately, we don't have a good way to actually change the soil or add rocks or add more soil with traction underneath the left side.
Okay, this one's from Roger Silber. Does the rover instrument arm have enough strength to provide a useful force vector to free the rover?
Unfortunately not. The arm can only exert about 15 to 20 pounds of force. It really can't do anything approximating lifting the rover or move any large rocks or anything like that. It's really only designed to just sort of gently contact the ground. It was never designed to actually really exert much force.
How much force could the arm exert if used in such an emergency sort of push-assist scenario?
Right, probably only about 20 pounds of force. So in a real emergency, we might give it a try. That might be the little bit of a difference that we need. But because that is such a risk to possibly damaging the arm, that's a long way off before we try that. But you know, as a last-ditch effort, we might give something like that a try, but it won't be much of a help, just a little.
Okay. This is an email question from Lee Wilkerson. The current position of the Spirit rover shows the right wheels on what appears to be a firm surface, with the left wheels mired in the soft soil layer. However, the rover in the test sandbox has all wheels embedded in the soft soil. Why was this scenario chosen for the simulation?
That's a really good question. So the particular simulant that we picked has some interesting material properties. If you pack it down tightly, it actually stays kind of firm and strong. But if you fluff it up, then it becomes loose and fluffy, like what we see under the left side. And we had really hoped that we'd be able to use one material, compact it differently, and have that work for both of the different types of soils we see on Mars. Right now, in fact, today, we're having a big meeting with the engineers and the scientists to look at the tests that we've already done and see if that assumption holds up. We are seeing some differences, and as a result of that, we may likely change that soil that's under the right wheels. So, excellent question, and we may be changing that for our next set of tests.
Well, here's another question regarding opportunity. Can opportunity help? And what is opportunity doing? And we have some video to show.
Great question. So opportunity is unfortunately on the complete opposite side of the planet. And given that they, have driven at most about 10 miles in 5.5 years, they probably will never meet each other. So unfortunately, opportunity can't help. But Opportunity, we've now got a video up that's showing basically Opportunity's entire 10-mile plus trek. She started at a little tiny crater called Eagle and then visited a larger crater called Endurance, and then drove several miles across some sandy plains to hit Erebus, which you're just about to see the video catch up there, and then headed off to a really large crater called Victoria, which we spent about a year exploring Victoria. And now we're actually heading towards the south, towards a huge crater that's miles across called Endeavour. And that is Opportunity's next goal. We're really hoping, this is a very old crater, it's very deep, but it's very eroded, so the sides are gentle slopes. So we're hoping we can drive deeply into that crater and see some really old layers that are exposed nowhere else that the rovers have been.
Did anyone ever imagine that Opportunity would be going that far?
No, I don't think anybody imagined that. Certainly we all sort of hoped and even maybe a little expected that we go far beyond our 300-meter design guideline. But in terms of 10-plus miles, no, I don't think that was in anybody's wildest dreams. But we long since gave up trying to bet on when it would end, because if you bet against the rovers, you're just going to lose. They just keep going.
But I guess we have to keep in mind that the rovers are getting older.
The rovers are getting older. They each have some faulty joints now. Spirit has a broken right front drive wheel, but Opportunity also has a steering motor on the right front wheel that's broken, and one of the shoulder joints is also broken. Now, gratefully, these have not done anything other than slightly slow them down. They certainly are still able to do much of their normal capabilities, but they are aging. We're sort of creating a new field, robot gerontology, because robots on Earth, when this happens, you just fix them. This is the first time we've ever been in an experience where we've had to continue operations with continually changing performance and degradation over this many years.
Well, you know, the subject of Opportunity keeps coming up, and they're asking, can Opportunity help? Well, Opportunity has helped.
Well, actually, yes, Opportunity did help. We wanted to do something a little bit risky with Spirit to help diagnose her situation. We wanted to take out the robotic arm and take a picture underneath the rover's belly so we could see the middle wheels, which we normally can't see how buried they were, see if there were rocks hung up on the rover. And because we were in some very complicated geometry, we didn't want to pull Spirit's arm out if we didn't think that this would actually be helpful. There was a risk of hitting it against a rock. So Opportunity actually did that first. We had Opportunity deploy her arm and take a picture underneath herself, and we got fabulous results. We could really see a lot of detail. So after we knew that it was going to be a worthwhile pursuit, we then figured out how to get the arm safely out and did take a picture, which has told us a lot. We, in fact, do have a rock that may well be touching the bottom of Spirit. We can see how buried the middle wheels are, which we couldn't see any other way. And so that has really helped our diagnostic problem.
And will Opportunity be called upon again in the future, do you think?
If there's another risky thing that we have to do, we may test it on Opportunity first, because Opportunity is in a much more benign terrain. It's much safer for her to try out new and different things. So certainly that could happen.
All right, so here's another question, another suggestion from our viewers. What about using very slow wheels continuously? Would that help get out of this soil?
That is an excellent question. That is one of the things we are considering. If you slow down the wheels, you might be able to get slightly better traction. If you're spinning fast, you're more likely to slip. And so that is certainly one of the things that in the next round of testing we are considering looking at. We don't know yet how well that will work, but that is an excellent suggestion, and we are thinking about giving that a try.
So how has the testing been going? Are you seeing certain things working, certain things not working at all?
Right. So we've done a bunch of testing. We've done forward driving, backward driving. We've done even some sort of sidewards crab driving, as we saw in the video a little while ago. And we are seeing the good news is, even though we think this is sort of a worst case model with really slippery soil and the wheels buried a little bit more than they are on Mars, we are seeing that the rover is able to move at least a little bit, even under these very adverse conditions. And so that has told us that we actually do have a good chance of Spirit being able to get out once we start this on Mars. At the moment, it looks like that we don't have quite enough data to really distinguish which individual things are going to be the best, but all of the things we've tried have moved the rover a little bit. We're very optimistic about this idea of possibly being able to crab and go slightly uphill. We do have, unfortunately, we'd like to rely on gravity in these situations, but downhill from us is an even worse sand pit than the one we're in. So if we could get uphill and away from these possible hazards, that would be a really good thing. So that's one of the things that we're definitely going to be looking at as well.
And once again, explain crabbing. It's
right,
going
so crabbing, so only the front and rear wheels on the Rover steer. But what we can do is we can steer those wheels at an angle and then drive them forward, and they're all driving in the same direction, which kind of pulls the Rover to the side a little bit. And we have used that before to try to approach science targets when they were off to the side of us a little, and it has worked very well. And in fact, we were using that to try to get us out of the sand pit originally before we realized we had these other potential hazards and needed to stop and reevaluate. And that was actually working somewhat. We were moving several centimeters each day. So.
Is there any similarity between what's happening to Spirit right now and what happened to Opportunity way back when it was going through the dunes?
Sure. Purgatory ripple is what you're talking about. Opportunity got fairly deeply embedded in a sand ripple. And yes, there are some similarities. The soil there was a little bit fluffy. We did get the wheels buried in very deep, and we had very little traction. We would try to drive a long distance, and we'd only move a few millimeters. So in some ways, the soil that we're in is kind of similar. The difference is that Opportunity was going uphill over a ripple and could then kind of use gravity to back straight down the hill through her tracks. We, unfortunately, Spirit's at a roll, so we to follow out our tracks, we don't get that extra little advantage of gravity helping to pull us down the hill. So we have a slightly more complicated geometry, but a similar problem.
Is Spirit more dug in, though, also?
Actually, Opportunity was pretty much as deeply dug in at Purgatory. Part of the problem was Opportunity drove about 40 or 50 meters before before she realized that she was slipping, because she wasn't looking where she was going at that point. That's very common to do when there are no obstacles around. We just let the Rover drive in what we think is a safe area. So it continued to spin the wheels after she stopped making progress for a long time, and it actually dug in quite significantly. So the rear wheels and the middle wheels were about as dug in as what we've seen on Spirit, but the front wheels were not as bad.
Something that lots of folks aren't familiar with is the fact that the rovers do kind of operate on its own with their own brains and autonomously. Were they operating autonomously? Was Spirit doing that?
Yes, in fact, so Spirit we had given her a path to follow, and she was autonomously trying to follow that path, and in fact slipped off that path to some extent and stopped the drive as a result of failing one of the own safety checks that she had in there. She realized she was off course and stopped. So yes, she was driving autonomously when this happened.
They have their own intelligence.
That prevented it from getting even further embedded and perhaps into a much worse situation.
Okay. Back to the questions. Can the science team conduct tests while you all attempt to help Spirit escape?
Yes. We have been doing a very extensive science campaign while we have been sitting in this location. We have tons of power thanks to the wind cleaning everything off. So we've been doing all kinds of science experiments. We have at least 4 different soil types that we can reach with the robotic arm, and we have done detailed analyses of all 4 of these soil types. We're continuing some further investigations today. In fact, we have brushed away the surface soil in one location, and we've actually gone down and seen that the soil changes like about a centimeter down. So we're actually investigating to see what that slightly deeper soil is. And we've learned that this soil is a little bit different than what we have seen elsewhere on Mars. It has a lot of sulfur in it, a little bit of silica, and I'm sure a scientist could tell you better what makes that unique, but it's a very interesting discovery that we have not seen anywhere else on Mars.
And any signature that would lend you to believe that water may be involved in any of this?
Absolutely. Whenever we find many of these mineral compounds, many of them are the result of water transporting these minerals to these locations and then evaporating away. And we've seen that at many locations all around home plate. And in fact, this is an interesting thing, is that we wouldn't have found nearly as much of this stuff and known it was nearly this widely distributed without the broken right front wheel, because it's mostly buried under the surface, and only by digging a hole, which the right front wheel does for us naturally most of the time, we've been finding these mineral deposits and salts in our tracks almost everywhere we go.
That's interesting, because here's another question. What have you learned from this set of difficulties in the design of new rovers? What have you learned that will help you design the next rover?
Right, that's an excellent question. And I know one thing that I would like to see on a future rover would be able to steer those middle wheels. If we could steer those middle wheels and have all the wheels help pull us sideways out of this stuff, that would be a nice thing that we could do. That would certainly be a big help right about now. Other than that, I can't possibly imagine what we could do to improve these rovers. They've lasted 5.5 years when they were designed for 3 months. They've been able to climb slopes much steeper than they were supposed to be able to climb. They've been able to cross sand dunes, which they were never designed to climb over. They've withstood massive sandstorms and been cleaned off. The people who designed and built this rover, who many of whom are friends of mine and colleagues of mine, they did an amazing job. I can't really imagine what else we could do to improve them. They're fabulous machines.
Would they ever consider putting, say, like a hoe that would drag behind and dig soil up, just like this broken wheel would?
Well, in fact, the next rover, the Mars Science Laboratory, is actually specifically designed to be able to core down even deeper than we can dig with Spirit's wheels and look at what's underneath the soil. So yes, in fact, we have learned how important it is to be able to get down below the surface. Phoenix, our recent lander mission, was designed to be able to dig down, as is the Mars Science Laboratory.
Okay, here's a question. Why worry about damaging the science instruments on the arm if the rover would otherwise be stuck?
Well, you know, that's a good question. I mean, the real answer is we are a science mission, and if we can't continue to fulfill our science objectives by taking measurements and analyzing rocks and soil, then you really have to ask yourself, is it worth driving somewhere new when you can't do much other than take pictures? So I don't know, and that's certainly a question well above my pay grade. You know, if it comes to that, I'm sure somebody else will be making that call. But I certainly hope it doesn't come to that.
All right. Well, we only have about 5 minutes left, so I'll try to go through a few more questions a little bit more quickly. Wasn't there some indication of the soil change through wheel resistance? And why wasn't Spirit stopped as it entered the soil?
Actually, there was no significant difference we looked very carefully at the currents on the wheels and all of this after we drove into the spot, and there was no obvious change in the telemetry that we could monitor. Unfortunately, because the resistance of the soil went down, but there were big piles of it around there, we're not getting a lot of traction, but the wheels are still experiencing some resistance. So that, unfortunately, we couldn't really measure that autonomously on board. But it did notice that it was slipping and off course, and it stopped for that reason.
Can all the wheels be turned independently? Well, you sort of...
Right, so the 4 steerable wheels can absolutely be turned completely independently, and all 6 can be driven independently.
But one of the 4 that could be moved independently is stuck, is it not?
Right, well, it can steer, it just can't drive, yeah.
Ah, okay, all right. And the rest of the question, so doesn't that give you a huge range of motions to try to get out other than forward and backward?
Well, and we have done a lot more than forward and backward. We have steered the wheels to the right at a couple of different angles and tried to climb uphill. We've steered the wheels to the left and tried to climb downhill. We've done the reverse, going backwards, doing that same thing, both trying to climb uphill and downhill. And we've even steered the wheels in a circle around the right front wheel, which kind of can act as an anchor in an attempt to try to pivot around that wheel and see if we can move the rover that way. And all of these things have shown some amount of motion, so there is potential that any of these things might be able to help us. And in fact, we are going to be discussing that today and tomorrow. We're going to look at all of our data and figure out exactly what the next things we want to test are.
All right. How about turning the wheels somewhere around 90 degrees from the front back axis of the rover and trying to go out sideways?
Right. Well, the wheels can only steer to about 60 degrees, so we can't quite get to 90. But we have done that testing, and that testing actually looks very promising. And right now, at least that's on my personal short list of things that I would like to be trying on Mars. Because, yeah, that can help us not only climb uphill away from the sand pit, it might help pull the left wheels out of the fluffy stuff and onto the firmer stuff that we see on the right side. So yes, that is a very good idea, and that is certainly on my short list of things to do.
Here's a little bit more of a personal question, and we get this all the time. How does one get a job as a Rover driver?
Well, me personally, I came to JPL right before we landed and never had any hopes of being able to work on this mission. It was supposed to be long over before anybody would let me anywhere close to flight equipment. But they lasted so long and were doing so well, they had to start hiring new people. And I'm a PhD in robotics. Robots are what I do. And I have to say there's a little bit of luck involved. My boss at the time was doing the Rover driver job. And so he recommended me as one of the new people to come in and start training. So.
And where does one major in robotics?
Well, there are two places in the country right now that offer PhDs in robotics. One is Carnegie Mellon, which is where I went, and the other is Georgia Tech. But a lot of places, either in the mechanical or electrical or computer science department, have a lot of robotics researchers. So there are lots of places you can go and study robotics.
Here's another one. This is cute. Has NASA considered contracting some dune buggy drivers and racers for their suggestions?
Well, we have certainly solicited, suggestions from anybody out there who wants to listen. Unfortunately, what the dune buggy drivers have that we don't is acceleration. These rovers go at something like 1/20th of a mile an hour, and you just can't build up any momentum like you would like to do when you're in one of these stuck situations.
You can't gun it and muscle through.
You can't gun it. Gunning it is very, very slow.
Can Spirit survive the winter?
Right now, we've gotten the solar panels nearly completely clean, and right now it looks like if nothing significantly changes, if we don't have another major dust storm, that Spirit will be able to survive the winter and probably won't even have to park.
Great. In the simulator, have you tried to back out?
We have tried going both backwards and forwards. The difficulty with going backwards on Mars is actually not too far behind the rover, which is almost level. The slope significantly increases. So before we go too far, we'd actually be climbing uphill. So we might try to back up a little bit to get away from whatever hazards might be around the wheels and then go forward again. But yes, we have been trying forward, backward, uphill, downhill, everything we can reasonably get the vehicle to do.
All right. Well, we've reached the top of the hour, but one more question. What's the time frame for trying all these great ideas on Spirit?
Well, we want to try these combinations of maneuvers first to see if there's any set of motions that seem to really be able to pull the rover out of this, and we may be doing that in a slightly different soil simulant. But we're hoping possibly as early as the end of the week of August 3rd. So toward the beginning to middle of August is when we really think we'll be starting to work on Mars again.
So we may be trying this out in just a few weeks.
Just a few weeks.
Wow.
And it's, not soon enough. Spirit is ready to go.
Well, good luck to you. And thanks
thank
for
you.
joining us. And thanks for joining us in the Cosmic Lounge here at the Jet Propulsion Laboratory in Pasadena, California. If you do wish to get updates, just go to our website, www.jpl.nasa.gov. Sign up to some of our feeds. And also Twitter, Facebook, Ustream, they're all there. Thanks for joining us. We'll see you next time.